So there they were, a sliver of it sitting on a lab bench, completely harmless looking, almost silvery, almost soft enough to slice with a butter knife. And the second it touched a single drop of water, it didn't just fizz, it screamed across the surface, hissed like something alive, and burst into a violent hot pink flame that could have singed your eyebrows off from 3 feet away. And get this, that exact same substance shrunk down into a tiny white pill is what stops people from taking their own lives. Same element, two completely different faces. One of them tries to burn the world down on contact. The other one quietly holds a human mind together, one dose at a time, for decades. And by the end of this, you're going to find out why scientists still can't fully explain either one of those things, plus a twist buried in your tap water that might already be shaping how you think right now, today, without you ever knowing it. Okay, here's the deal. We're talking about lithium, element number 3 on the periodic table, the lightest solid in the entire known universe. So light, it actually floats on water right before that same water sets it on fire. And I gotta be honest with you, the deeper you dig into this thing, the weirder it gets. It's sitting in your phone right now, quietly powering the exact screen you're watching this on. It might be in your kitchen tap. It was literally born in the first 3 minutes of the universe's existence, before stars, before galaxies, before literally anything else had formed. And somehow, this one tiny, unassuming, silvery white metal sits at the crossroads of cosmology, brain science, geology, and the entire future of clean energy. And at every single one of those crossroads, it is still, to this day, keeping secrets from the smartest people on the planet. 6 mysteries, real ones, unsolved ones, not we're 99% sure but haven't gotten around to publishing it yet mysteries, actual gaping holes in human knowledge that top researchers argue about in conferences in real time with real frustration, sometimes with real careers riding on who turns out to be right. And by the time we get through all 6 of them, I promise you, you will never look at your car battery, your tap water, or the night sky the same way again. Let's start at the very beginning, like the actual beginning of everything that has ever existed. In the first few minutes after the Big Bang, and I do mean minutes, not years, not centuries, minutes, the entire universe was this insanely hot, insanely dense soup of pure energy and brand new particles slamming into each other at unimaginable speeds. There was no you, no Earth, no sun, not even any atoms yet, not really, just raw, seething, formless creation. And as that furnace expanded and cooled even just a little bit, it started cooking up the very first chemical elements that would ever exist anywhere in the cosmos. Mostly hydrogen, a big, generous helping of helium, and then, almost like an afterthought, a tiny, tiny pinch of lithium formed in that same 3-minute window before the universe cooled too much for the reactions to keep going. Here's the part that should honestly blow your mind a little. The physics behind this exact moment is so locked down, so mathematically precise, that scientists today can sit at a chalkboard and calculate the exact ratio these elements were supposed to come out in. It's basically a recipe card written at the dawn of time, and we have the ingredients list completely memorized, down to the decimal points. And for hydrogen and helium, the math is close to perfect. It matches what our telescopes actually observe out in deep space almost exactly, down to fine decimal points that would make a physicist weep with joy. But lithium? Lithium breaks the recipe completely. Not a little off, not within the margin of error, broken. See, when astronomers point their most powerful telescopes at the oldest stars in the observable universe, and we're talking about stars that formed from material barely touched since the Big Bang itself, basically frozen time capsules drifting quietly out there in the dark for over 13 billion years, untouched, unpolluted by later generations of stellar recycling, they only find about 1/3 of the lithium that the models say absolutely has to be there. 2/3 of it, just gone, not hiding somewhere obvious, not miscounted by some lazy grad student staring at bad data, missing. And here's the part that genuinely gets scientists worked up at conferences, sometimes into actual shouting matches over coffee and bad hotel Wi-Fi. Nobody agrees on why. Hold up, though, because I need you to really sit with this for a second. This is not some tiny rounding error that physicists are quietly sweeping under the rug and moving on from. This is a full-blown crack running straight through our understanding of how the entire universe began. And there's more than one camp fighting over the explanation, each one convinced the others are missing something obvious. Camp number 1 thinks the missing lithium got swallowed up by the very first generation of stars and destroyed in nuclear fires before we ever got a chance to observe it. Basically, the stars ate the evidence and left no fingerprints. Camp number 2 thinks something way stranger is going on. They think invisible dark matter particles, the stuff we still can't directly detect with any instrument on Earth, despite decades of trying, somehow interacted with the early universe and quietly erased part of the lithium through some exotic process we don't fully understand yet, something we might not even have the physics vocabulary to describe correctly. And then there's a smaller, bolder camp, a handful of physicists who've gone even further out on a limb, wondering out loud whether the actual fundamental constants of physics, the real numbers that govern how gravity works, how light behaves, how atoms hold together in the first place, might have quietly drifted just slightly over the past 13 billion years, which, if true, would mean the universe doesn't run on fixed eternal rules. It runs on rules that slowly shift under us, like sand. Sit with that for a second. We are not talking about misplacing a receipt in a junk drawer. We're talking about losing 2/3 of an entire element that is mathematically guaranteed, by our own best equations, to exist from the birth of everything. The missing cosmic lithium is basically a ghost that crashed the universe's own birthday party, uninvited, and nobody can figure out how it got in, or where it slipped out to afterward, or whether it's even still out there somewhere disguised as something else entirely. And until somebody solves that, our entire origin story, the one taught in every astronomy textbook on the planet, has a hole punched straight through the middle of it, right at the foundation. So here's a question for you. If lithium is this ancient cosmic troublemaker, something even the universe itself seems to be actively hiding from us, how in the world did this same element end up saving human lives inside a psychiatric ward less than 100 years ago, almost by pure accident? Let's jump forward, way forward, all the way to 1949. Australia. There's a psychiatrist named John Cade working out of a converted, rundown shed at a repurposed veterans hospital. And he's doing something that, if we're honest, is pretty gross by today's standards. He's injecting guinea pigs with the concentrated urine of his manic patients, hunting desperately for whatever toxic compound might be causing their wild, uncontrollable mood swings. He figures if he can isolate the poison, maybe he can finally understand the disease that's tormenting these people. To make the concentrated urine easier to actually inject into the animals without irritating their tissue, he dissolves it using lithium salts, purely as a technical fix, nothing more. He's not testing lithium, he barely thinks about it. It's just a convenient carrier. And that small, almost invisible decision is the exact moment everything changes. The agitated, frantic guinea pigs, the ones bouncing off the walls of their cages, clearly distressed, clearly suffering, go calm, quiet, almost serene, like something deep in their nervous system just finally exhaled after holding its breath for too long. And Cade sits there, staring at these suddenly peaceful animals in total disbelief, realizing completely by accident that he might have just stumbled onto one of the single most powerful psychiatric treatments in human history, hiding inside a chemical he only added to solve a lab logistics problem. Fast forward to right now, today, in hospitals all over the world, and lithium is still the gold standard treatment for bipolar disorder. It's not experimental. It's not a maybe this works, maybe it doesn't. It measurably stabilizes extreme highs and extreme lows, and it measurably reduces suicide risk in a way almost no other psychiatric medication on Earth can currently claim. Even decades later, even with entire new generations of drugs designed specifically to try to replace it. Millions of people are alive right now, functioning, working, raising kids, showing up to birthdays and weddings and ordinary Tuesday mornings because of this one soft, silvery metal that a guinea pig accidentally discovered in a shed. And here's the kicker. More than 70 years later, thousands of research papers deep, entire academic careers built from start to finish, studying nothing but this one single drug, and nobody, not one team, not one lab, anywhere on the planet with any amount of funding can tell you exactly how it works. Not fully, not completely, not to the level of detail we demand from almost every other modern medication. See, most modern psychiatric drugs are built like a key cut for one specific lock. They hit one receptor with surgical precision, and that's basically the whole mechanism, start to finish, clean and simple. Lithium is the total opposite of that. It's a blunt instrument, a gentle sledgehammer swinging around in the dark. It messes with a dozen different biochemical systems, all at the exact same time. It tweaks neurotransmitter signaling throughout the brain. It resets the body's internal circadian clock. It interferes with a sugar-like signaling molecule called inositol, and it even seems to protect brain cells from slowly degenerating over the years, almost like a quiet insurance policy running in the background. It's like lithium walks into a chaotic orchestra where every single instrument is playing something completely different, all at once, all wildly out of tune. And instead of silencing any one of those instruments, it just quietly retunes every single one of them simultaneously, without a conductor, without a script. And somehow, impossibly, harmony comes out the other side. And listen, if we ever actually crack how that works all the way down to the mechanism, that's not just solving one riddle about one drug. That could rewrite the entire future of how humanity treats mental illness, period. Full stop. But hold up, because we are nowhere near done here, because this same quiet healing metal has a much more violent past that honestly doesn't even make sense on paper. See, here's a fact that, based on everything else we know about how stars work, really shouldn't be true. Most stars in the universe are actually lithium killers, not neutral toward it, not indifferent, actively chemically hostile to it from the moment they're born. When a star is born, one of the very first things it does, almost immediately after ignition, is swallow up whatever lithium it inherited from its birth cloud and burn it away completely in nuclear fires. And it does this even at relatively low stellar core temperatures compared to the reactions that power the rest of the star's life. Stars destroy lithium. That's simply their default behavior, baked directly into stellar physics from day one, no exceptions. So here's the actual problem this creates, and it's a real head-scratcher. If the universe's own stellar engines are basically factory-built to annihilate this element wherever it shows up, why is there enough of it sitting under our feet right now, today, to fill entire mirrored salt flats in South America, power a global fleet of electric vehicles, and get mined by the ton for ceramics, greases, and heat-resistant glass? For decades, this was a legitimate, unsolved cosmic whodunit that geochemists genuinely argued about at length. The Big Bang made a small amount of lithium, sure, but nowhere close to enough to explain the massive deposits we actually find scattered across Earth's crust. So where did the rest of it actually come from? Something had to be manufacturing it quietly after the Big Bang was long over. The answer, it turns out, involves rare, violent, almost cinematic events happening across deep space over billions of years. Novae, that's when a dying star, usually one locked in a close binary orbit with a companion star, has a sudden explosive outburst on its surface, flaring bright enough to be visible from other galaxies for a brief moment, can act like brief temporary lithium factories, spraying freshly created lithium out into interstellar space in the chaos of the blast. And separately, high-energy cosmic rays have been ripping through the galaxy for billions of years at close to the speed of light, slamming into heavier atoms atoms like carbon and oxygen floating in interstellar gas clouds, and literally chipping fragments of lithium loose in the collision, like some invisible cosmic sculptor chiseling away at solid stone one impact at a time, one atom at a time, for billions of years without ever stopping. And here's the part that'll mess with you a little. Scientists are still arguing right now, today, in actual published papers about which of those two sources contributes more lithium to the galaxy overall, and neither camp is backing down, which means the lithium sitting in your phone battery at this exact moment, in your hand or your pocket, might be the leftover debris of a star that violently exploded millions of years before Earth even existed, or it might be the tiny wreckage of a single cosmic ray slamming into a random carbon atom somewhere out in the depths of space, ages before our sun ever formed. Either way, something violent somewhere out there had to happen just so this one fragile element could survive long enough to end up powering the device you're watching this on right now. All right, real quick, gut check. We've covered the ghost lithium that's been missing since the Big Bang. We've covered the psychiatric miracle drug that nobody can fully explain even after 70 years and thousands of papers. We've covered how this fragile little element somehow survived every star's least favorite meal over and over across billions of years of cosmic history. And we are just getting started, because the next mystery, this one might already be affecting you right now in your own kitchen without you having the faintest idea it's happening. Here's the part that's going to mess with your head a little more than the rest. Scientists studying completely different, unconnected parts of the world, Oita Prefecture in Japan, small rural towns scattered across Texas, quiet villages in Greece, mountain communities tucked into the hills of Austria, and a handful of other regions since then, all independently stumbled onto the exact same pattern, without originally even looking for it, without comparing notes, publishing decades apart in completely different languages. In towns where the natural tap water happens to contain slightly higher trace levels of lithium, rates of suicide, rates of violent crime, and even rates of dementia all show up measurably lower than in nearby towns with less lithium in the water, sometimes towns just a short drive apart. And to be crystal clear here, we are not talking about therapeutic doses, not remotely close to the kind of dose given to someone diagnosed with bipolar disorder. We're talking about microdoses, a few thousandths of a milligram per liter of drinking water, an amount so vanishingly small, it's basically a whisper, chemically speaking, almost nothing at all when you actually put it on a laboratory scale. And yet this exact pattern keeps showing up again and again in countries that share almost nothing else in common. Different governments, different diets, different climates, different cultures, different languages entirely. So here's the question that should honestly unsettle you a little if you actually let it sink in for a second. Is lithium some kind of essential micronutrient for the human brain that modern medicine has simply never formally accounted for, the same way we already account for iron or vitamin D in our diets? Have we spent the last century filtering, purifying, and treating our water supplies for safety, and in the process, accidentally stripped out a naturally occurring low-dose mood stabilizer that entire human civilizations were unknowingly drinking for thousands of years, long before anyone even understood what an element was? Now, to be fair, scientists are careful here, and you should be too, because correlation is not proof and it never will be on its own, no matter how many times the pattern repeats. There could be other things quietly going on underneath all of this. Different regional diets, tighter community and family bonds, cleaner air, even different regional standards for how suicide and violent crime get reported and recorded in official statistics. But some biologists argue, seriously, in peer-reviewed journals, not on some fringe blog, that there's a real biological threshold at play here, a minimum daily amount of lithium that your brain's own cells might genuinely need for basic repair processes and healthy emotional regulation, the same way your body needs a baseline amount of iodine or zinc to function properly. And if that turns out to be true, we might currently be running a centuries-long, completely uncontrolled experiment on the minds of entire populations, with no control group, no informed consent, and no clear idea yet of how it ends, or what we've already lost by filtering it out. But hold up, because as unsettling as your own tap water might suddenly feel right now, it's got absolutely nothing on what's sitting buried under the Nevada desert at this exact moment, waiting. Picture this, the high desert stretching along the Nevada-Oregon border. Dry, empty, windswept, the kind of place where you could drive for an hour and not see another car, just sagebrush and heat shimmer on the horizon. 16 million years ago, this exact spot exploded, a supervolcano, one of the most violently powerful eruptions in Earth's entire geologic history, a blast that would dwarf anything in recorded human memory, anything a human being has ever witnessed, tore itself apart from the inside, and then collapsed inward into a massive basin, like the ground itself caved into its own open wound. Over the following thousands of years, that basin slowly filled with a warm, alkaline lake, fed continuously by volcanic hot springs absolutely loaded with dissolved lithium, bubbling up from deep underground, mineral-rich and steaming. And as fine volcanic ash rained down into that lake, century after century after century, layers stacking quietly on layer, something happened that geologists still cannot fully explain, even with all our modern instruments and analysis. The lithium didn't just wash away downstream the way basic chemistry would normally predict it should. Instead, it concentrated. It packed itself, layer by patient layer, into a soft, greenish clay called smectite, quietly building what would eventually become the largest known lithium deposit in the entire United States. Geologists have actually started calling it the clay of the future, and it's sitting there right now, today, holding enough lithium to power the country's electric vehicle ambitions for decades to come, all thanks to a chemical accident nobody fully understands. We know the basic ingredients that went into building this thing: violent volcanic fury, rare, very specific lake chemistry, unbelievable, almost incomprehensible amounts of geologic time, more time than the human mind can really grasp. But the actual step-by-step process, the precise chemical alchemy that trapped all that lithium in one exact spot, instead of letting it slowly leach away into the surrounding groundwater like it logically should have, the way lithium behaves almost everywhere else on Earth, that part is still fiercely debated among geologists right now in ongoing active research, with new papers still coming out. And if scientists ever fully crack that recipe, we might be able to locate dozens of similar hidden lithium vaults buried all over the planet, geological gifts quietly left behind by ancient catastrophes we haven't even identified yet, sitting under deserts and mountains we've never thought to look under. But here's where it gets messy, because everything we've covered so far, the missing cosmic lithium, the psychiatric miracle nobody can fully explain, the star-defying survival story, the whisper hiding quietly in your water, the supervolcano's buried treasure vault, all of it has been building this entire time toward one final unsolved problem. And this last one, this is the mystery standing directly between us and the actual clean energy future we keep being promised by every headline, every keynote, every car commercial. Because right now, today, there's a phantom haunting the quest for the ultimate battery, and it might just be lithium's most dangerous secret of all. Here's the dream, and it's not far-fetched at all, not science fiction, not decades away. If we could build a battery using pure lithium metal instead of the heavier, safer materials we currently rely on, an electric car could realistically travel from New York to Chicago on a single charge, no stopping, no anxiety about the battery gauge ticking down. That's not some far-off fantasy. That's real, achievable chemistry sitting within our technical reach today, this year. But the second you actually try to charge a battery built like that, something goes catastrophically wrong every single time, without fail. Under a microscope, the lithium atoms refuse to form a smooth, clean, flat layer of fresh metal the way they're supposed to. Instead, they start stacking themselves into jagged, needle-like spikes. Scientists call them dendrites, and like some kind of cursed forest growing in fast forward, sprouting where nothing should grow, these spikes push relentlessly through the battery's liquid interior, hour after hour, charge after charge, until they physically pierce straight through the internal separator, cause a dead short circuit, and because lithium is so violently reactive with almost everything around it, ignite a fire that is nearly impossible to extinguish once it fully starts, one that can reignite hours later, seemingly from nothing.
And after literal decades of dedicated, well-funded research, genuinely brilliant scientists still don't fully understand why lithium behaves this way at the atomic level. It's this insanely chaotic, tangled interplay of electric fields, ion movement, and microscopic surface imperfections, all colliding at once, at a scale smaller than anything you could ever picture with the naked eye, smaller than a single bacterium. Instead of atoms lining up in orderly, even rows like disciplined construction workers building a wall brick by brick, they behave like a panicked crowd, stampeding for a single exit, piling recklessly on top of each other, climbing over one another to get out first. There are fixes emerging in labs right now, this year, as we speak. Solid electrolytes, clever pressure techniques, ultra-thin protective coatings designed to guide the lithium into behaving itself. But the actual root cause, the fundamental physical reason lithium turns suicidal and spiky the moment you push it too hard, is still not fully solved. Not completely, not to anyone's satisfaction. And taming that dragon isn't just some niche chemistry project tucked away in a university basement lab. It's the literal gatekeeper standing between us and a world that runs entirely on the lightest, most electric element that exists anywhere in nature. So think for a second about everywhere we've traveled together in the last half hour. A ghost that's been missing since the very birth of the universe itself, 13 billion years ago, never found, never explained. A metal that quietly calms the human mind without a single scientist on Earth fully understanding how. Saving lives it can't fully explain saving.
A star killer that somehow, against its own violent nature, filled the Earth with treasure anyway, through pure cosmic accident. A whisper hiding in your water that might be quietly shaping entire societies without their knowledge or consent, one glass at a time.
A supervolcano that accidentally built a hidden vault worth billions of dollars 16 million years before anyone would need it. And a battery breakthrough dangling right in front of us, so close we can almost touch it, guarded by a dragon made of spikes in unquenchable fire. 6 mysteries, one tiny 3-letter element. And honestly, we've barely scratched the surface of what's out there, because it turns out lithium isn't the only element sitting in this exact position. There's another one out there, way lighter, even weirder, present at the very birth of everything, just like lithium was, cooked up in those same first 3 minutes of existence. And its story might be even stranger than this one. That one's coming next.